Good day, students. Today we're going to talk about domain and range. Domain and range. It's from chapter 4. It's in book 2 of ma1026 booklets. I've taken examples from page 62. So these are on page 62 of your text, page 62. But I just want to talk about domain and range only. I'm going to use a couple of videos here. This one I'll talk about it from these examples, and the next one I'll talk about it from graphs. Okay, so let's have a look at domain and range from these examples. Now, when you're asked for domain and range, the words are very simply put. Domains are the x values. Okay, so domain, D-O-M-A-I-N. Now I'm just going to use the letter capital D from now on for that, okay, for domain. And remember, that is all the x values in use. What x values are being used by that relation or function. And of course, range, I'll use the capital R for that from here on in. And they are the y values that are being used in the relation or function. Now, from a set of ordered pairs, the very first example, the domain and range is quite easy. So if you look at example 1 right here, you see a set of ordered pairs, a very fixed set. Okay, you see brackets at the end of each, so it's only 4 ordered pairs. So the domain is simply and you can use domain brackets or set brackets. You just list out the x values, usually in order. Now I go from lowest to highest, -1, see the -1 there, and that's used twice. I don't need to repeat it, and it looks like 3 is the other. So there's only 2 x values in use. 3, there they are, and -1. Okay, so that's simply how you state the range. The domain. The range are the y values used by that same relation here, and again we'll go from lowest to highest, and it looks like it's 2, 4, 6, 8. So domain and range from a set of ordered pairs very easily. And the second example there, number 3, is also giving you a relation or function. We'll talk about that later, which one is a relation, which one's a function, in another video. So here we have a domain and range. What x values are in use? So the x values here from lowest to highest are 0, 3, we got 3 again, don't need to repeat it, 6. And the range here is, the lowest is -6, then we go to -3, 0, +3, and +6. So there's the domain and range. So from these two, it's quite easy. Also, it's also easy from a mapping diagram, right? M-A-P-P-I-N-G. That's mapping. Looks like let me just fix that. Looks like an R. Okay, so mapping, M-A-P-P-I-N-G. Now in a mapping diagram, you're seeing with arrows. For example, I'll rewrite the table of values in number 3. This is called a table of values. So that they could also be done in a mapping diagram, and it would look like this: X, Y as column headings, and then the number 3 would map to 3, but would also map to -3. Right? The 6 would map to -6 and 6, and 0 maps to 0. So I could rewrite it as a mapping diagram. So the first 3, or set of ordered pairs, table of values, or a mapping, are quite easy for domain and range. Now on the bottom you see 4 different equations. This is where it becomes a little bit more difficult. Okay, recognizing what each one is would certainly help. Also knowing that you're looking for restrictions, things that you can't have, or things that, if for example if I square every x value, I'm going to get a positive y value. So you're looking at conditions and restrictions. So now it'd be much easier if we could look at the graph of these. So let's look at the first one here. under the letter V, number 5. Okay, y equals 2x minus 3. Now you should recognize that already. You should recognize that as a line, right? As a linear function, where you have a slope of 2 and a y-intercept of negative 3. Now if it's a line, then there are no restrictions on what x values x can be, right? Therefore, no restrictions on what y would be here. See, so the domain and range is every x value, is every real number, in both cases, for both the domain and range. Difficult to explain, but better if you see it visually. So let me see if I can bring up my graphing calculator here. Now let's just type that in. Y equals, and we got 2x minus 3. Let's look at a picture of that line. Now you probably had that in your head anyway. Positive slope, so slants upward to the right. Right, has a y-intercept of negative 3, and this goes on and on and on forever. So there's no restrictions. Every x value is in use in this relationship, or could be used. Every y value could be used. So for simplicity's sake, we're just going to say, okay, that for all linear functions, okay, the domain is simply all reals. Now you can write it out in words, all real numbers, or you can use function notation, or which is x such that x belongs to a real number system. And the range, by the way, is exactly the same here. Domain is all real, or range is all reals as well. Y such that y belongs to. See, there's no restriction. That linear function goes on forever and ever. Every x value, every y value can be in use here. Next one, okay, number 6 there. Now that's a different ballgame, and we're going to study those later on in this chapter. People who recognize it from high school or from other courses. This is a quadratic function. Okay, it's called a quadratic, and it's actually in the shape of a parabola when you graph it. Okay, but where there's a square involved, right there, x squared, that's going to be conditional on the y. Okay, now ask yourself, are there any restrictions? The key word is, are there any restrictions? Is there something I cannot put in here for x? And the answer to that question would be no. There's absolutely no restrictions. So the domain here, again, is all reals. And I'll write it out in words this time. However, the range is conditional upon the domain in this case, and we can see that every x value is squared. And sometimes it helps to look at a table of values. So let's do both. Let's look at the graph and look at the table of values. So over here, I'll just do up a table of values for y and x squared. So here's x and here's y. So I'll just put in a couple of negatives, say negative 2, negative 1. I'm picking these out of my head, 0, 1, and 2. And I'm going to put them in for y. So if I put, now remember, y is x squared. So if I put 2 in here for x, I get 2 squared, which is positive 4. 1 squared, positive 1. 0 squared is 0. Now what happens when it's a negative? So y equals negative 1 all squared. What happens? Of course it does. Yes, it becomes positive, right? So it's positive 1. So every x value I put in there, when I square it, it's going to become a positive y value, no matter what x value I put in there. So you'll notice that in the range here, look what's happening. All the values are positive. The lowest value you can have is actually 0 when you put 0 in. So what does that make in the range? Well, let's look at it graphically again, quickly. Let me bring up my graphing calculator. What happened to it? I seem to have lost it. Let's go find it. Okay, give it a second to come up here. There we go. Now, let me bring it down here. There we go. You should see it there now in the video. So let's go back to y equals. This time I'm going to clear that and put in x squared. Now watch what happens when I graph that. So you see it's a parabola, but notice down on there's no negative y values being used. None. they're all above or on or above the x-axis. So it's always positive y. Okay? Always positive y. Therefore, the range is this way. Y such that y is greater than or equal to 0. And again, y belongs to the real number system, but I don't have a lot of room there, so I'll leave that out for now. Alright, let's look at the next one. Now the next one again, it's difficult to tell from the domain and range from equations is the most difficult concept of domain and range. Okay? So if we look at the next one, y equals 1 over x plus 2. Now remember, are there restrictions? Think of that word, restrictions. Yes, we know there's a restriction this time. We know we can't have division by 0. So I have an x in the denominator. So what would make that 0? So when you have x in the denominator, what would make that 0? Yeah, that's right, negative 2 would make that 0. So that means x cannot be negative 2. It can be every other x value, but not negative 2. So the domain would read like this time. X such that x cannot equal negative 2. Now, what does that mean? That means every other x value except negative 2 is part of the domain. So we're saying that negative 2 is the only number that cannot be part of the domain. Okay? Now the y becomes a little bit more difficult here. Okay? In this rational function. How do we determine what y cannot or can be? Well, one trick is to solve for x. Some people use this trick here. They'll actually solve this for x and look at y. Okay, they'll take this, cross multiplies. This is understood to be over 1. So you get y times x plus 2 equals 1. Then divide by y. I'm going to solve for x this time. So x plus 2 equals 1 over y. Or x equals 1 over y minus 2. Well, what do you notice? We got 1 over y. So when you have 1 over y, that means y cannot be 0. Because you'll have 1 divided by 0. Alright, just one way to look at it. And there's many ways you could look at this graphically again in... I'll bring up the graphing calc. This is a rational function, by the way, what we call a rational function. And it's asymptotic. In other words, it has asymptotes. We'll look at that later on in the course, I think. So the range here is y such that y cannot equal 0. And that's a difficult concept to get the range. Most people can get the domain here, but they have trouble with the range. Okay? But when the right hand side cannot equal 0, like that, the left hand side cannot equal 0. So again, so there are many ways to look at these, and if I wanted to look at that graphically, just let me bring it up again. Let's have a look at this one. Y equals, and it's 1 divided by, use brackets around the bottom, x plus 2. And we'll graph that. Now you notice that there's a line here, okay, that x cannot equal negative 2, see? So it breaks it up into a piecewise graph or two-piece graph. Okay? So that's a little bit more difficult, that one. Alright. Now the last one is y equals the absolute value of x plus 1. Now this is an absolute value equation. And it might help us to graph that right away. So let me bring back the calculator. Let's graph that one right away. What does an absolute value graph look like? Alright, so let me see if I can find that now. Might be under catalog. There we go. Absolute value of x plus 1. X plus 1. And I'll delete and delete. That looks right. Okay, let's graph that. Now it's a big letter V right at negative 1 and 0, right? It's the vertex of it. So what do you notice? No negative x values, or y values. No negative y values. So the domain is going to be, what's the lowest y value? See it there? It's 0. So the range is y greater than or equal to 0. Now, look at all the x values being used. Every x value is in use here. Okay, so looking at it graphically really helps in this case. Or do up a table of values and look at the table of values, right? So if you want to then look at the table of values and scroll down through that, you can see, right? all positive y. I scroll up here to the negative side. Look, all positive y values. Because absolute value means, right, the distance from 0 to the number, and therefore distance can't be negative. So because the absolute value signs are around the whole thing, that means y can never be negative. So the domain here for this one, right, x belongs to the real number system. In other words, that's all real numbers. So some people write it like that. And the range here is y such that y will be greater than or equal to 0. So a difficult concept, domain and range, from equations. Much easier from the top part, table of values, ordered pairs, or mapping. In the next video now we'll look at domain and range from graphs.